Hi everyone, Frankie here. So today I'm going to be showing you the manganese chemical chameleon experiment. So we're going to be preparing a solution that changes colors over time. Now, the substance that causes the color change is the manganese ion. Manganese has many stable oxidation states. And when it changes oxidation states, it also changes colors. So let's get to the science behind it. So here's a periodic table. Manganese is found within the transition metals. It is element number 25. Now the transition metals are known for having many stable oxidation states. And each of those oxidation states often has a different color. So by changing the oxidation state of the manganese, we're going to change the color of the solution. So allow me to further explain what an oxidation state is. An oxidation state is an electrical charge. Now, depending on what electrical charge you're dealing with and what element you're dealing with, it will absorb and reflect different wavelengths of visible light. And of course, the different wavelengths of visible light will have different colors. So, the way you change an oxidation state is you can add or remove electrons. So here in our potassium permanganate solution, it's purple in color, we have Mn plus 7. This has an electrical charge of positive 7, giving it a purple color. Now we're going to be adding electrons to the manganese to turn it into the Mn plus 6 ion, and that is green. And then we're going to add more electrons to turn it into Mn plus 4, which is brown, but will appear yellow or orange in color because the insoluble MnO2 particles will be suspended in water. If you let the solution sit for a while after the reaction is complete, you'll start to see the solid accumulate on the bottom of your container. So, we're going to use table sugar to add electrons to the manganese and cause it to change colors. Now, if we just add the two together straight up, the manganese gets very greedy and will go right to Mn plus 4. So we're also going to be using sodium hydroxide to slow the transfer of electrons so that we can better see the color change. In basic solution, potassium permanganate will reduce a lot slower. So the two solutions you're going to need is a 1e to the negative 4 molar solution of potassium permanganate. Now to make that, all you need to do is add 20 milligrams of potassium permanganate to a liter of distilled water. The other solution we're going to be using is 1 molar sodium hydroxide and 0.06 molar table sugar, sucrose. Now to make this solution, you add 40 grams of sodium hydroxide to a liter of distilled water. And then you add 20 grams of table sugar to that same solution. So the sucrose in the solution is going to add electrons to the manganese to change its oxidation state, thereby changing its color. And the sodium hydroxide is going to make sure that happens slowly. Make sure you wear gloves and goggles when you're doing this experiment because sodium hydroxide is rather corrosive and potassium permanganate can be toxic if ingested. Alright, so here I have 400 milliliters of potassium permanganate solution. Now, per 100 milliliters of potassium permanganate solution, you're going to need 25 milliliters of sodium hydroxide and sucrose solution. So, here I've got 100 milliliters of our other reactant solution. Now note that this is a very large excess of sucrose. This is not stoichiometric, but it's necessary to add a large excess so that the color change will proceed at a reasonably fast rate. So, all we need to do at this point is mix the two solutions, 400 milliliters potassium permanganate solution, 100 milliliters of sodium hydroxide and sucrose solution, and watch the color change. So the manganese has just gone from the +7 oxidation state, which is purple, to the +6 oxidation state, which as you can see is green. Now, the manganese will then go to the +4 oxidation state, although it will do so much more slowly than it went from +7 to +6. Alright, so after about another minute and a half, we're starting to see the green color slowly transition to a yellow-orange color. This means that the manganese is now slowly but surely going from +6 to +4. So as you can see, the solution has now turned orange. This is due to the Mn+4 ion. Now, it stops at the Mn+4 ion because this reaction produces manganese dioxide, and MnO2 is not soluble in water, so it will join back together and stop transferring electrons. And it creates the suspension of tiny particles of manganese dioxide, giving the solution an orange appearance. Now, if you let the solution sit for a day or two, then you'll see the manganese dioxide fall back down to the bottom and the solution clear up. Now, this experiment can also be done with chromium. Chromium has many stable and colorful oxidation states, and vanadium. So, I'll experiment with that a bit, and once I perfect it, I'll definitely publish that too. So, hope you guys enjoyed. I'll see you in the next video.